welcome back. This is the third video for the first organic chapter that we started, that is haloalkanes and haloarenes. In the previous videos, we discussed about type of hybridizations of the carbon atom to which the halogen is attached. Second video, we discussed about nomenclature. Today, we will discuss about methods of preparation of haloalkanes. Now, there are quite a number of methods, so I'll divide my lecture into different parts. Okay? The first method is from alcohols. Now, all of you know that the general formula of alcohol is ROH. Okay? Now, what is the method? We need to treat the alcohol with a halogen acid, that is HX. Now, we treat this with HX. What is eliminated then? You can remember this reaction in this manner. So, the products are Rx plus H2O. Clear? Let's take an example. I'll take the example of ethanol, CH3, CH2OH plus HCl. We will use anhydrous ZnCl2 and our products will be CH3, CH2Cl plus H2O. This is chloroethane or ethyl chloride. Done? Now, when we do this process, that means we choose an alcohol and we treat it with a halogen acid in the presence of anhydrous ZnCl2. This method is called Groove's method. G-R-O-V-E'(S). This is Groove's method. Okay? Second, this is a primary alcohol. I hope you understand. Secondary alcohol, let's choose CH3OH, and this is H. So this is propan 2-ol. Let's treat this with HCl and the same anhydrous ZnCl2. We'll get CH3CH3Cl plus H2O. So this is 2-chloropropane. Right? Now you must understand the function of anhydrous ZnCl2 here. Anhydrous ZnCl2 acts as a Lewis acid. Okay? Acts as a Lewis acid and it will help in the cleavage of this carbon-oxygen bond. If it does so, then this will form a carbocation, which we will see in the mechanism next. It forms a carbocation to which your halide can easily attack and get the product. Okay, so this is about primary and this was the secondary halogen. Let's see what happens in the tertiary case. Tertiary alcohol. Tertiary alcohol. So CH3, CH3OH plus HCl. Now, you must remember that tertiary alcohols are very reactive. You don't even need to add anhydrous ZnCl2 in this case, and the reaction can take place at room temperature. Okay, and you will get your tertiary alkyl halide. Clear? So this is 2-chloro-2-methyl-propane. So this is about all the products that we have prepared were chlorides. Let's see about bromides and iodides. Okay. Next, see, for chlorides we take HCl. That means for bromides we should choose HBr, and for iodides we should choose HI. We must remember that HBr and HI are not, available as such. If you need HBr and HI for any reaction, you need to prepare that in situ. That means it has to be prepared in the reaction media. Let's see how it can be done. Okay? So I'll straight away take the alcohol CH3, CH2OH, and we will take KBr plus concentrated H2SO4. Okay, HBr, and you will get CH3CH2Br plus KHSO4, that is potassium bisulfate or potassium hydrogen sulfate plus H2O. You can also write the reaction in another manner, that is CH3CH2OH plus HBr directly. Okay, concentrated H2SO4 and heated, you will get CH3CH2Br plus H2O. Okay, so this was about bromoalkanes. Let's see what happens if we want to prepare iodoalkanes. For iodoalkanes, let us take the same example, ethanol CH3CH2OH plus KBr, Ki, since it is iodo. We cannot use sulfuric acid. We have to use phosphoric acid, H3PO4. Okay, and we will get this. We need to reflux this. We will get CH3CH2I plus KH2PO4, potassium dihydrogen phosphate plus water. Okay, now why have we chosen phosphoric acid for this reaction? In fact, in some books it is also written that for HBr also they use phosphoric acid. What is the reason behind this? We have to understand that concentrated sulfuric acid is a strong oxidizing agent. Okay, it is a strong oxidizing agent. So if you have Ki plus H2SO4, you are supposed to get I2 plus SO2 plus H2O. Okay, that means most of your HI is oxidized to iodine, and it is not available for reaction with the alcohol. That is the reason why we use phosphoric acid. Clear? So these are the products for the reaction of ethanol for preparation of iodoalkanes and bromoalkanes. I hope this is understood, so that we can proceed to the next. Alright, so these are reactions on which there will be exercises. Okay, now notes. That means important points to remember. Mechanism of the reaction, first of all. Alcohol plus the proton that has come from the acid. Oxygen contains lone pair. Fix this up with my alcohol. Okay, you get ROH and H plus. This is the protonated alcohol. Okay, protonated alcohol. Next, X minus, that means this is my nucleophile now that has come from the halogen acid, will attack this protonated alcohol. Okay, so it attacks here, this goes away, so we get Rx plus H2O. So you must remember what is actually happening in the reaction. Okay, so if you follow this mechanism, then we will learn about how different halogen acids show the reactivity towards an alcohol. We have hydrogen iodide, hydrogen bromide, hydrogen iodide, HCl. Okay, the reactivity of this hydrogen halides towards any alcohol, the order is HI is more reactive, then HBr, and then HCl. Why is this so? This is because the I minus, that means this nucleophile that will be formed, has more tendency to donate its lone pairs to the carbon compared to all others. This is in accordance with bond dissociation enthalpy, which you studied last year. That means HI bond is weaker, that means it can dissociate easily compared to HBr and HCl. I hope you remember why it is so. because iodine atoms are much bigger than bromine and chlorine atoms. Okay? So this was the order of reactivity of halogen acids. What about reactivity of alcohols? Reactivity of alcohols. Okay? Tertiary alcohols are more reactive than secondary, which are more reactive than primary again. Why is this so? We saw here that due to formation of protonated alcohol, a carbocation will be formed, which I will show you in the next reaction. We know that the order of stability of carbocation is tertiary is more stable than secondary is more stable than primary. Class 11. Okay? Tertiary carbocations are more stable than secondary than primary. That is why when we took that example of tertiary alcohol, we saw that the reaction took place at room temperature. Okay? So, one thing I'll tell you, it is not possible for me to write down everything in the note and provide it to you. So, this time, if there is anything that I have missed in the notes, please write it down from the videos. Okay? I am too much under pressure. School, tuition, home. Okay, let's continue. Okay, now there is one very important and interesting question that is not board level, but it is usually related to entrance questions. The question is, why is neopentyl chloride neopentyl chloride cannot be prepared by action of HCl on neopentyl alcohol. Cannot be prepared by neopentyl alcohol. Okay, this is the question. Why can you not prepare neopentyl chloride by the action of HCl on neopentyl alcohol? Okay, let's write the reagents first. Neopentyl chloride. Those who have done the exercise, they know this is neopentyl alcohol. Done. Now, we have HCl, so this will have H plus minus Cl minus. This will pick this up. So we will have the protonated alcohol CH3C, CH3, CH3, CH2, OH2 plus. Done. This will leave, that means minus H2O, resulting in the formation of a carbocation CH3, CH3, CH2 plus. This is a primary carbon atom because this is attached to only one more other carbon atom directly. This is the primary carbocation, and to increase the stability, what happens? This adjacent methyl group shifts here. So we will call this 1,2 methyl shift. 1,2 methyl shift. So what happens? CH3, CH3, CH2 and CH3, now your positive charge comes here. And this is obviously tertiary, which is much more stable. Now your nucleophile, that is Cl minus, will attack here and we will get a tertiary alkyl halide. CH2, CH3. Okay, so you must remember this. Alright, now this reaction I have not written, so you must do it from the board. I am rubbing it off. Next. So we are done with preparations of alcohols with halogen acid. We'll go to the next slide. That means alcohol from phosphorus, PHOS, PH4, minus phosphorus halides. Okay. Treatment of alcohol, we have done with 8 halogen acids. So next we will do with phosphorus halides. We are still under alcohols, okay? Okay. So first we will do chloroalkanes. Chloroalkanes. Let's start. I'll just take the general formula. So ROH, the phosphorus halides that you will be using are phosphorus pentachloride. PCl5. The product that you will get is RCl, that is your alkyl halide, plus POCl3 plus HCl. Now, how can you remember this? There are 5 chlorine atoms, so one goes with this, one goes with this, and we are left with POCl3. This is the general reaction. Let's take an example. CH3, CH2OH plus PCl5 will give you CH3, CH2Cl plus POCl3 plus HCl. So you must remember this reaction. I'm telling you, this is very important. This and the next one. Second one is alcohol plus phosphorus trichloride will give you RCl plus H3PO3. We'll balance the reaction first. 3 here and 3 here. So with your alkyl group part goes the chlorine and the rest will be your phosphorus acid. Let's do the same example. CH3, CH2OH. Sorry, this is PCl3, phosphorus trichloride. PCl3. So this becomes 3, 3, CH3, CH2Cl plus H3PO3, phosphorus acid. Okay? So this is chloroalkanes. So we have to do bromoalkanes and iodoalkanes separately. Okay. Next is bromoalkanes. Bromoalkanes. Now, okay, so for bromoalkanes and iodoalkanes, we need to treat the alcohol with red phosphorus in presence of bromine and iodine. Let's take the example CH3, CH2OH, red phosphorus in presence of Br2. This will actually give you PBr3, okay? This will give you PBr3. So your products will be CH3, CH2Br plus H3PO3, following the same rule, that PCl3. If this one is given, no need to write this. If this one is given, no need to write this. Okay. Similarly, CH3, CH2OH, red phosphorus and I2 will give you CH3, CH2I plus H3PO3. 3 here plus PI3. Clear? So this is for bromoalkanes and iodoalkanes. The last method. And the most important one. Okay? That is, number 3rd preparation is thionyl from thionyl chloride. Okay. The formula of thionyl chloride is SOCl2. Okay. So we'll take the alcohol plus thionyl chloride in presence of an organic base, that is pyridine. Alright? What are the products? The alkyl halide plus sulfur dioxide plus HCl. How to remember? R goes with Cl, another Cl, SO2. Done? Why this method is important? First of all, we have to remember that the name reaction is Darzens method. Darzens method. Both SO2 and HCl are volatile gases. They will be eliminated from the reaction medium and you are left with only the alkyl halide. So this is one of the most suitable methods for preparation of chloroalkanes. Let's take an example. CH3, CH2OH plus SOCl2 pyridine. This will give you CH3, CH2Cl plus SO2 plus HCl. Okay? So, ethyl chloride. So, these are the methods. We did halogen acids, we did phosphorus chlorides, and we did thionyl chloride. 3 methods of preparation of haloalkanes from alcohol. In the next video, we'll choose other methods. Okay, thank you everyone.